So now we'll discuss about differential relay. Differential relay is defined as the relay that operates when the phase difference of two or more identical electrical quantities exceeds a predetermined amount. So from the definition, the differential relay has two actuating quantities, that is current. Two or more quantities should be similar, that is current and current. Differential protection is generally unit protection. So the protection zone is exactly determined by the location of current transformers and voltage transformers. Types: current differential relay, biased percentage differential relay, voltage balanced differential relay. Current differential relay, the main principle is, let's assume a power transformer with transformation magnitude relation 1:1 and YY connection, and therefore current transformer 1 and current transformer 2 ensure a similar transformation magnitude relation given in the diagram, that is current differential relay. So differential relay at normal condition. The current flows within the primary side and secondary side of power transformer are equal, ideal power transformer. The secondary current I1 and I2 are same in magnitude and reverse in direction. So therefore the net current within the differential coil is nil at load situation, and therefore the relay will not operate. So external fault condition in differential relay. So in this figure we can see, during this case, the two currents I1 and I2 can increase to terribly high magnitude values. However, there is no modification in phase angle. So here the net current within the differential coil continues to be 0, and therefore the relay will not operate. Internal fault condition in differential relay. So here there are two anticipated conditions. You can see in the diagram there is other supply to feed the fault. Thus I2P includes a non-zero value, I difference equal to I1S plus I2S, which can be terribly high and sufficient to function the differential relay. That is, the radial system I2P is equal to 0. Here you can see the protected winding, and I2 equal to I1 for normal condition, and I2 is through fault condition, and the relay coil is present, and I difference is equal to I1S, and additionally the relay can work and disconnect the breaker. Next is the mesh price protection. So here the reason for using this modification is, circulating current differential relay is to overcome the trouble arising out of the differences in current transformer ratios. So in this relay, the operating coil is connected to the midpoint of the restraining coil, becomes the sum of ampere turns in its two halves. So for external faults, both the I1 and I2 increases, and thereby the restraining torque increases, which prevents the mall operation. So for external faults, both I1 and I2 increases, and thereby restraining torque increases, which prevents the mall operation. And the relay is so called based differential relay because the restraining coil is also called biased coil, as it provides additional flux. The percentage of biased differential relay has a rising single peak up characteristics. Next is the voltage balanced differential relay. So here the relays are connected in series with a pilot bias, one at each end. So the relative polarity of the current transformers is such that no current through the relay under normal operating conditions and under fault conditions. So during internal fault, the condition changes as an equivalent current I1 plus I2 by 2 flows through the relay coils at each end. So the current transformer used in this such production is with air gap core, so that the core does not get saturated and over voltages are not produced during this zero secondary current under working normal condition. So this is the voltage balance differential relay diagram. So through fault condition differential protection based on balanced voltage principle, overcurrent relay 1, overcurrent relay 2, and protected equipment I1 and I2 is placed. So when fault occurs, the voltage balance differential relay is activated.